Hey friends, welcome to Embed Idea. I am Tirthankar and you are watching 8051 course for beginners. In this lesson, I am going to interface a Matrix keypad with 8051. So, this is lesson 11 and in this lesson I will discuss what is a Matrix keypad and what are its uses. Then Matrix keypad scanning methods and how to print on 7 segment, that I will also cover in this lesson. And at last I will show you a phone keypad experiment. So let's begin. So what is a Matrix keypad? Suppose for a project we need 12 functions and those functions will be enabled through keys. Now there is one solution, that is to connect 12 buttons at 12 microcontroller pins, and there is another solution, that is we can use a matrix formation keypad where we can get more combinations with lesser pins. Like see this one, this is the example of a phone keypad. So here there are 4 rows and 3 columns. So this is called a 4x3 phone keypad. Here we can get 12 combination. How? 4 into 3 and with 4 plus 3, that means 7 pins. That is the beauty of matrix keypad. And how normally we scan a matrix keypad? There is a scanning method, like the row pins will be configured as output. See, these are the row pins R0, R1, R2, R3, and there are 3 column pins, and column pins will be configured as input. Then I'll select a row and I'll read the columns. That is the main technique. And if a button is pressed, then the respective row and column will get short. Like here I am giving 0 to row 0 and rest of the rows are at 1. So here I'll read column 0 first. If column 0 is 0, that means 1 is pressed. If column 1 is 0, then button 2 is pressed. If column 3 is 0 or column 2 is 0, then that particular 3 button is pressed. Similarly, when I am selecting row 2, here see the sequence 1 0 1 1, that means I am reading row 2. And if column 0 is also 0, that means 4 is pressed. If column 1 is 0, then 5 is pressed. If column 2 is 0, then 6 is pressed. Similarly, I will check for 7 8 9 and star 0 hash. But here in the experiment we will print only 0, not star and hash, because we will be using a 7 segment. So there is no scope for printing special characters. So this is how we can scan a keypad, and this is the standard method. So see, this is the 7 segment interfacing technique. So in case of 8051 ICs, the output current is very low. That's why I'll interface a common anode 7 segment with 8051, and that is the standard case for any 8051 applications. Normally we use common anode 7 segment. So in common anode, all the anode pins of the LEDs are short and connected to one pin. That pin is common, and we should apply a 5 volt there, and rest of the pins will be activated through 0 volt. So in this case the microcontroller is acting as a syncing circuit. So see how we can print 0. A, B, C, D, all are, these are LEDs. So there are 7 LEDs, A, B, C, D, E, F, G, and there is a dot, and dot we can call that dot is as a decimal point. Here I have organized the bits as a table. So to print 0, what we should give is, in all the digits the decimal point is deactivated. That's why I have given 1. 1 means off, 0 means on. So to print 0, only G will be off and rest of the bits will be on. And the value, if we calculate that value in hex, it will be C0. Similarly for 1, only B and C will be on and rest of the pins will be off. that is calculated as F9. Similarly, for 2 it is A4, for 3 it is B0, and for 9 it is 90. This will be required in our code. So now I'll do one experiment where I'll connect a keypad with 8051 and I'll check the keystrokes and print the respective digit on 7-segment display. So let's perform the experiment. So to save your time, I have already written the code here. See, this is I have defined 3 columns, column 0, 1, 2, which are connected at P2.4, 5 and 6, and the segment port is P1. And I have declared a prototype of a function which I am going to use, that is display. Then inside void main I have configured the P2 as partially input and partially output. Inputs are the column pins which are connected at the upper nibble of that particular port, and the lower nibble will be connected to the row pins. Those are configured as output. That is why I have written F0, means 41 and 40. Segment port is configured as output, that's why I have written 00 over here. Then inside while one, this is the scanning method. A loop is incrementing a variable which I have declared here from 0 to 3. So there will be 4 iterations, 0, 1, 2, 3. In switch case, I have given the variable I. So in iteration 1, case 0 will be executed. In iteration 2, case 1, then case 2, and then case 3. So there will be 4 iterations. In case 0, I am sending FE. FE means all the row pins are 0 except row 0. E means 1, 1, 1, 0. That means I am selecting row 0. And that time I am checking whether column 0 is 0 or not. If column 0 is 0, then display 1. Otherwise, display 2. When column 2 is 0, display 3. Similarly, in this case, this is FD. Now see, D means 1, 1, 0, 1. Now I am selecting row, second row, and I am checking for column 0, 1, 2 and display 4, 5, 6. Similarly, FB, B means 1, 0, 1, 1. And now I am selecting row 3 and I am checking for key number 7, 8 and 9. And at last 7 means 0, 1, 1, 1. That means I am checking the 4th row and I am only checking for column 1, and if column 1 is 0, then I am displaying 0. So in the display function, I am sending one digit here like display 7, 8 or 9. So that digit is going to the switch case, and if case 0, then segment port C0. See, I have got these values from that table. So C0 is for 0, F9 is for 1, A4 is for 2, and similarly 90 for 9. So this is the simple case. So this is my code. Now let's simulate it. So let me build it first. It's already built because I have tested it. Let me open the simulator. So this is my circuit. So 7 segment is connected to port 1. See, the common pin, I have connected it to positive voltage 5 volt. And this is the phone keypad. A, B, C, D are row pins which are connected at port 2.0, 1, 2, 3. These pins are output. And 4, 5, 6 are connected to column number 1, 2 and 3. So this is the simple circuit. So I have already located the hex file. So let's go to debug and locate the keypad hex file. Now switch on the simulation. So here if I press 1, see 1 is getting printed, then 2, then 3, then 4, then 5, then 6, then 7, then 8 and then 9, and it is 0. So my circuit is working perfectly. The code and the circuit diagram is given in a link, and that link is given in the description box. You can download the code and the circuit from there. I hope you have learned a new thing. So if you like this video, then press like, share it with your friends, and don't forget to subscribe to Embed Idea. And also, this is the end lesson of this course, and later on I'll show you few 8051 projects. So stay tuned and watch Embed Idea.